The stable salt reactor is a revolutionary clean energy concept, but one with unusually low technological hurdles. This simplifies almost everything about the reactor, resulting in power that is cheaper than fossil fuels. This can be done now without lengthy research, combining long-proven components from conventional nuclear with innovative molten salt technology. All reactors today have their nuclear fuel contained in small pellets. These pellets are stacked inside a fuel rod several meters long, and a single reactor has thousands of fuel rods. The pellets and rods are sealed, and over time they build up radioactive gases to huge pressures. They have to be kept hot enough to produce heat for electricity, but not too hot, otherwise they will melt. This is a real engineering challenge, and people have succeeded, but when something goes wrong, it can be catastrophic. The high pressure gases can burst out and be spread for hundreds of miles. In our reactor, we replace the pellets with liquid molten salt, which contains the nuclear fuel. This is a stable liquid at atmospheric pressure, which brings numerous advantages. Firstly, the fuel in our reactor is 2/3 table salt and 1/3 uranium or plutonium chloride. The uranium can be enriched natural uranium, U-233, bred from thorium or plutonium, reprocessed from spent nuclear fuel. Unlike today's methods, our process for recycling spent fuel is simple, cheap, and does not leave a waste stream that is dangerous for thousands of years. The molten salt fuel is contained in fuel tubes and sits in a large assembly, very similar to assemblies in conventional reactors. Molten salts have excellent heat transfer properties, and they are chemically stable and can operate at high temperatures still at atmospheric pressure. This means there is no risk of a high pressure explosion or need for costly pressure domes. Lots of these assemblies fit into our core. The use of molten salts also means the reactor is self-controlling. This means that if the temperature goes up, the reactivity will go down, making it inherently safe. And if the temperature goes down, the reactivity goes up. This makes it very stable and effective at load following with intermittent renewables. Now let's talk about gases and fission products. With the SSR, the hazardous gases that have released to the atmosphere in accidents in the past, such as cesium and iodine at Chernobyl, are not in the form of gases. They are stable compounds in the salt, so this accident can't happen. Other gases slowly bubble out of the top of the fuel tube. So what about materials and corrosion? For us, the only component in this high energy region are the fuel tubes. These are replaced every 5 years for fuel efficiency reasons. Other components are far less affected by the neutron flux because the neutrons are almost all absorbed by the pool of molten salt surrounding the core area. We've essentially eliminated corrosion issues by making sure the molten salt mixture is chemically stable and non-corrosive. We've applied the old science of galvanizing to this modern challenge, using zirconium instead of zinc. So what can go wrong? Well, if the heat extraction system fails, the reactor, like all reactors, will overheat. But we've installed entirely passive air cooling ducts around the outside of the tank to ensure the system can always be cooled down without intervention. If the tank gets very hot, the air in the red ducts starts to heat up, and cold air is drawn in via the blue ducts. This is sufficient to keep any size reactor at safe temperature without ever needing emergency intervention. Without the need for expensive features to contain hazards, cheap, clean energy is finally possible. Our costs are also reduced by our modularized design. Each module is transportable by road along with the entire reactor tank, even for a 1 gigawatt plant. enough to power about 2 million homes. This is all designed with the intention of having a factory line, producing many units, meaning large-scale rollout of the SSR is possible, fast enough to have a real impact on global climate change. Our design philosophy, from mine to end user, is to have an energy system that has little to no impact on the environment in any setting, whether it's an urban surrounding or a more prominent coastal one. We need to produce cheap, clean energy for the world, as the world needs it now. Thanks for learning about the Moltex Energy Stable Salt Reactor. If you'd like to find out more, check out our YouTube channel or our website www.moltexenergy.com.